Good morning, everybody. I hope you are doing well. So today we are going to do 800 to 1200 rated code forces practice. Okay. So let's see. I think I should. I think everything should be valid, I guess. So let's set the difficulty from 800 to 1200. We will not be focusing on any specific tags. We'll just be randomly solving problems. So we will try. Will not any, not just. Let's solve this problem and Oracle. So this is the first question. You can try this question by the way. So implement a quantum oracle of n qubits, which implements the following function. Uh, yeah, so if of this, my code should have the following signature. This does not look like a standard problem. Let's see something else like oracle for this. And let's not solve from this. Surprise round. Well, I think I should have more filters, I guess, that it should be from some code forces division rounds, not just random. I think we have a lot of 800 rated problems, but let's start with a 1000 rated problem, that is raspberries. Okay, let's try to solve this problem. You were given an index of integers or array of integers and a number k, and you can perform a following operation, like basically choose an index and increment that index element by 1. So we want to know what is the minimum number of operations we require to make the product divisible by k. Okay, so 67 plus 3 is 10. So 10 is already divisible. So the answer should be 2. Okay, is from 2 to 5. Choose an index I from 1 to n. Yeah. Okay, sorry. 7 is a 21. 21, I think 21 is not divisible by 5. Uh, so I have to go to the 25, I guess. So 25 minus 21, that is 4. But it's saying that. But if I say it's 5 to 6, then 6 to the 12 and 7 to the 14. Or if I do like 5 into 3, sorry, 7 into 3, it's 21. Let's try. Say 7 and 3 is given. So 7 into 3 is 21. So not divisible by 5. If I increment this to 4, so 7 4 is 28. If I increment this to 8, then this is 8 4 is 32. So maybe not this. Okay, 7 into 5 I will guess probably it will work because 3 to 4, 4 to 5, 7 5 is 35, which modulo 5 equal to 0. K is from 2 to 5, that is the constraint. So the idea for, let's say if K is 2, we have to only worry about some cases. So if K is 2, we know that the last number, if it is even, I mean last integer if it is like if the product is even, then we are good to go. If k is 3, then sum of digits. If k is 4, then last two digits, right? If k is 5, then we only worry about the last digit being 5. Okay, let's see. So, for example, if we want to check divisibility by 2, and let's say some product is given. Now, let's say the product is odd. Now, that means a product is odd. That means it has odd number of odd numbers. Like, or let's say it has, let's say I have 3 into 3 into 3 into 2 maybe. Like, even if one even number is present, then that will be uh, done. So, that will be divisible by 2, I want to say. Otherwise, if all of them are odd, like, so I can increment any of one of them. So first I will do the product and check if it is odd. If it is odd, then my answer is 1 because I can increment any of the elements by 1 and that will make that number even. So that is the solution for 2, k equal to 2. If k is 3, then the sum of digits, if it is divisible by 3, then I am good to go. Now, the sum can be either 0 modulo 3. In that case, my operations is 0. It can be 1 modulo 3. In that case, my answer is 2. If it is 2 modulo 3, then the answer is 1. Okay. Now, if k is 4, then I only worry about the last two digits of the number. So I can do the product modulo 10, 100 I mean. Now, product modulo 100 can either be 0 modulo 4, 1 modulo 4, 2 modulo 4, or 3 modulo 4. Now, let's think about this 4 situation. Uh, or we can think of this as we need to have, let's say, let's do a prime factorization of the elements. I need to have two twos. So it's like it has to be divisible by 4. So I need two twos. So in the end, I want to check that if the prime factorization has two twos. Same with 5. In my prime factorization, I want at least, uh, but the problem with this finding two twos is we cannot take care of increments. Like what will happen if any of the element is incremented, right? Let's check for some test cases. Maybe we can find some pattern. So we have solved for k equal to 2, 3, and 5. I think we can do it like, let's say this is an element A and this is an element B, C. We have some elements, right? Now 5 requires, in the end, I need a 5 or a 0. So it's like, but the problem with this is that if I increment B by 1, it becomes B plus 1. So maybe what I can do is uh, uh, calculate distances from every element, and it says that AI is up to 10. So it's not like that AI will be very big integers. So if AI was up to 9, mm, so let's say let's take some cases like 741, like 741, 7 for the 28, so 28. And you see, if we do make this a 5, we are done. Like n is up to 10 to the power 5, that means if AI is up to 10, then the product is up to 10 to the power 6. So the finding the product and maybe storing it is not a problem. So is not an issue, even though we can do module or something. If we don't basically require to do any module as we find the product. Uh, so I'm thinking maybe find the distance from 5 for every element, and let's print out the minimum distance. Uh, Also, let's say if one of the element is 10, in that case, again, so maybe distance to 10 will also work. Like if the element is 9 into 1, I can make this a 10. No? Yeah, that will work. So that is the solution for 5. What about 4? 4 requires the last two elements being divisible by 4. So the last two elements of the product can be 1, 2. I mean, it can be anything like, mm, I mean, last two digits, I mean, sorry. It can be from 1, 1, 1, 2 to 1, 9, then 2, 1, 2, 2, 2, 9, 3, 1, 3, 9, 9, 1, 9, 9. But this will not work because let's take this example like 3 into 4, 3, 4, and 6, 3, 6. So 6 is 18. So 36 into 3. So 18 carry 1. 108. Now this is 8. So I don't need any operation. So 6, the answer should be 0. 1, 2, 3, 4, 5, 6. Yeah. Um, can I say that I need twos? Like 6 I have. I can do 6 by 2. Or I want to calculate the power of a prime in 6. Yeah, if all of them are odd, then there is no 2. Then my answer is 2. Like 3, 3, 3. Now if I make this 3 into a 4, then I'm done. But if I make a 6 into a 2, 6 into a, like, if I make a 5 into a 6, then that only contributes 1 2. But if I make 3 into a 4, that contributes 2 2s. So for example, 3 5 3 is given. Uh, assume 3 5 3 is given. Wait. Yeah, assume 3 5 3 is given. In that case, I have two options. I can make 5 into a 6, or I can make 3 into a 4. This is what I will choose. Like this is modulo 4 3. This is modulo 4 1. So maybe for every integer, I will check what is its modulo 4. Now, if any of them I find modulo 4 0, I am done. If one element I find at least with modulo 4 equal to 3, then my answer is 1. Otherwise, my answer is 2. I think this is the right course of action. Let's try. Let's try to implement this now. So maybe let's create a new folder, I guess. Just 1 second. Just give me a moment. I'm just renaming something. Hmm, yeah, I think it should work now. Let's parse this. We don't need this. So let's say we take integer n. We have test cases for this code. So int n, I think same. Say this n being implemented. I think I should have a k as well. Okay. So we have our input. So let's say if k equal to 2, then I will check how many odd numbers are there, right? Uh, so v, I will just check that. How many odd numbers are there? If x and 1, then plus plus, I guess. We don't have to do anything if it is there are only odd numbers. So let's say count all. Otherwise, In the other case, print, I guess, 1 else. If k is 3, then I will just count all the sum of digits. So maybe sum is, yeah, it is up to 10 to the power 6, so it will not be a problem. So maybe sum d, I will check if sum d modulo 3 equal to 1. Then my answer is print 2 return. Sum d modulo 3 equal to 2. In that case, I have to print like if it is 0, I print 0. If it is 1, I print 2. If it is 2, I print 1. Right. Otherwise, print 0. Now, else if k equal to 4, then I basically count number of course, I have to do this. Like basically mod 4 3 and mod 4 1 I have to count. What if mod 4 2 is the idea? Yeah, I think that I will also do. So mod 4, a mod 4 2 equal to 0, a mod 4 1 and mod 4 3. Now, so basically if I do that, if x mod 4 0, then I just print 0 and return, right? If x mod 4, then m for 1 plus plus. Else if x mod 4 is 2, then m for 2 plus plus. Else m for 3 plus. So if I like if m for 2 is greater than equal to 2, then also we print 0 return. We don't have to return, I guess. Else, then I will check that if I have at least one M43, then we print one return. Now let's do for 5. If k is 5, then the idea was that we will calculate distance from 5 and 10 of every integer that is being multiplied. So t equal to absolute. Actually, I think it's a minimum and absolute 5 minus x and absolute 10 minus x, I guess. And we just print the minimum. It's try to run. In all the prints it did this should be print again. We do have some logical problem, I guess. Okay, so the second case, that is 3, 3 and 9, I mean 7, 8, 9, 10, 11, and 12. If case 3, sum is 0, 7, 8, 9, 10, 11, 12. Okay, okay. Let's have the debug template. Loading is very slow, I guess. Why? Okay, so it says its sum is 12. So we are printing 0 only, no? Okay, the answer is 2. Why? 7 for the okay, it's not product. If sum of digits of the product. Yeah, not just sum of digits. I mean, okay, okay. Mm, product equal to 0. Mm, okay. So maybe okay. So 2, 2, 1. Then again 2. So 2, 2, 1. So 5, 5 we have. Okay. Okay, we have a 5. So it will be in this case. Okay, int equal to 0, I guess. Okay, okay, int max size. Two to 1, and then 2. Why? Okay, let's try PR this D. So this D is 2. I don't need this sum D anymore. Well, let's try to isolate this case also. 5, 5, right? Okay, so D is 0. Yeah, that's what I expected. So println D. So, okay, I have to include D as well. Otherwise, that's an issue. No? It's not like the minimum of every word. It has to be the, it has to take minimum with itself as well. Like, it cannot just continue. Okay, why? Okay, abs goes to labs. Well, let's get a probably start LL. From the plus one. Should not matter. Like abs have set as labs because this kind of returns double. And so double and int is not directly compatible. Okay, minimum. Uh, okay, then let's take int only. And let's say this is int of abs. Okay, so we have traveled some distance like 2210, 2210, 2020, and then 221020, 221020. Yeah, and then we have a 2. So one, two, three, four, five, six, seventh test case. So 1, 2, 3, 4, 5. Like 1, 2, 3, 4, 5. So 3, 4. Okay, 6, 5. 6, 5. So 30, 30, right? Uh, okay, 6 is what kind? I think 6 is modulo 4 3 kind. No, sorry, modulo 4 uh, 2 kind. And 5 is modulo 4 uh, 1 kind, right? Yeah, 6, 1, and 5. Like if I find a modulo for 2, okay, so let's take the seventh test case. Uh, okay, 615, right? Modulo for 2 is 1, it's not the case. Modulo for 3, what about modulo for 1? We have not considered any modulo for 1s. Like my output is 2, but the answer should be 1 because 6 5 is 30. Like 1 I can upgrade to a modulo 4 2, right? Yeah. So let's say I have some number of modulo 4 ones and only one modulo 2. It's like 2 and then a series of ones. Then I can upgrade one of them. It's like 2 I have, and then I can upgrade one of them. So this will become a 2 then. Yeah, that is one way. So I can just say that for 2, I know that modulo 4 is not greater than equal to 2. It's modulo 4 plus modulo 4 1 equal to 1 and greater than equal to 2, I guess. Then also I think I can bring it to 1, right? Okay, let's try to bring this one. Yeah, it's correct this time. Okay, so 2 2 1 0 2 2 1 0 1 2 1 0 2. Okay, so this one has failed. No, 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 I cannot have that. It's like, no, I have to say if, else if, like, I have to go inside. For 1 is greater than equal to 1, and M for 2 is also greater than then only I do. Otherwise, it's not like 1 1 1 1 I can have. Then I have to operate two of them now. Or is it? Sorry, sorry, I have to upgrade. Yeah, M4 2. 2 2 1 0 1 2 2 2 1 0 2 1 0 2 2 2 1 0 2 0 1 2 0 1 1 1 1 2 0 1 1 4. Okay, 1 2 3 4 1 2 3 4 okay, 2 5 and 1 6. Okay, 6. The distance from 6 to 5 is, yeah, yeah, yeah. Understand? So I have to do 10 minus 6. Yeah, I don't think I can do that. Yeah, this will probably work. Let's try. Let's see if it passes the test cases. Yeah, so still maybe not perfect. Let's see where we have failed. Okay, 27th numbers. So to find the 27th is this. Will it be visible after that? 1, 2, 3, 6, 7. Ten. Okay, so 4 to the 8. Yeah, now I can upgrade this 5 to 4 to 5. No, no, it's a 4. So 8 5 is a 40. Here the modulo 4 is directly 0. How is this fail? Let's try this. Otherwise, it's not the 27 case, I guess. Let's try all of these. So let's try up to, yeah, let's try all of these. How many I have? I think around 1, 2, 3, 4, 6 I have. Okay, so 5 ones are 5. Yeah, so 2, so easy. 8 to the 16, the answer is 0. 10 for the 40, answer is 0. 10 is 30, answer is 0. 8 5 is 40, the answer is 0. 3 to the 6, like 3 into 2 I have. And I will check for divisibility by 4. My answer is 1. Why? Because I can just upgrade this to a 4. Yes, correct. Um, any expectation? Expected 1 found to 27th numbers. So let's take up to 27 only. 2, 4. Let's take up to 27 only. And we are only concerned with the last displays. Okay, it's 2, yeah. But what is the 27th one? Okay, maybe they don't make this P or decent. Can I try like let's try to send this T. T equal to 27, then maybe P. Hmm, T is being printed, right? How many times is 27 coming? Okay, I can send I. Okay, 2, 3, 2, 5. 5 to the 10. Okay, so sum is 7. So modulo 3 is 2. Sorry, 5 to the 10, I think. Yeah, 5 to the 10. So product modulo is 1. Then my answer should be 2. But it's saying I can make this. Yeah, I can make this 2 into 3 then. So no game of product. I just have to count modulos only. Like like how many numbers? So the fourth case only. So suppose this cannot be ever possible. 2, so M3 2 and M3 1 and M3. If M4 3 is 0, then no. If 3 is 1, then M4 1 plus plus M3 2 plus plus. Now we have to check that if I have some number of, if I have a 2, mm, this is a 2 situation, right? This is a 1 situation. If I have a 2 or a 1, just print 1. No need to, I mean, okay, the first one has failed this time. Where is my answer 2? Let's check the upper one. 2 to 1, 2 to 1, 0, 2, 0, 1 to 0. Okay, the second one is 2. Okay, 7, 3, 3, 3 are 9. The answer should be 0. Wait, not 7, 3. Oh, sorry, sorry. 7, 4, 1. 7 for the 28. This is modulo 3, 1 situation. And this is modulo 3, 1 situation. This is also a 1 situation. This is not modulo 3.1 situation. This is modulo 3.2 situation. Okay, if modulo 3.2 greater than equal to 1, print 1. Yeah, this is probably very concrete. The last one, it should be 1, 2, 5, 5 to the 10. Don't laugh at my compilation error. It was just a test. Uh, yeah, it's accepted. Uh, let's try to solve the next problem. I think I took a lot of time solving this one, around 1 hour. Not an issue. Let's try to solve another problem of possibly 1000 only. Yeah, dream on and stairs. Okay, so dream moon wants to climb upstairs n steps. He can climb 1 or 2 steps. Wants number of moves to be a multiple of n. Okay, what is the minimum number of moves required to satisfy his condition? Okay, first is I guess n and m. So to climb 10 steps, and I want every number of moves to be a multiple of 2. Okay, normal DP situation, order of n DP, that will get me number of ways to reach n steps. But the only condition extra here is that he wants a number of uh, moves to be a multiple of m. So the number of moves can either be m, 2m, 3m, 4m, and so on. Uh, but this is exactly like the Fibonacci, but one condition. Let's take, so let's say we have uh, n, right? We can take 1 step or 2 steps. If we take 1 steps, that is k is 2, so k is up to 10. It's not like k can be any a big integer. Mm, I think this will be a three-dimensional DP, like a two-dimensional DP, where here in the third dimension, I can probably store number of moves I have done modulo k. That's what I'm thinking. So So it will be n dp, it will be n by this 10, I guess, because modulo k can be up to, if k is up to 10, then modulo k is from -0 to 9. Now, how to define transitions? I mean, I have to define the states first. Like, so I can just say that dp of I b equal to number of ways to reach, I mean, climb I steps such that I modulo k equal to b. No, in my in that case, then no, I uh, is this a good approximation? So number of ways to climb steps, I steps such that I modulo k is b. B is up to, of course. B can be from 0 to 9. Like if k is 2, then b is 0 and 1. Okay. Let's take some example like 10. Okay, so n is 3, right? And m is 2. Yeah, m is 2. So what will be dp of 1 comma 0? It will be how to climb one step such that, like, I want 1 modulo 2 equal to 0, which is impossible. Okay, it's just asking print a single integer and the minimal number of moves being a multiple of n. And let's say I find out the overall minimal number of moves. Okay, let it be x. Uh, can I say that I have to find the distance of x from the nearest multiple of m, right? And then I can probably find the difference as ceiling division by 2. That will probably work. It's not like I have to do it for every case. Do I? Let's try. So, so int n and m. So let's say, uh, let's have a recursion only. I, what is the minimum number of steps to do once? Okay, for example, 3 and 5. Where is it not possible? At what? I wanted to climb 3 steps while being a multiple of 5. It's impossible. What if I wanted to climb 5 steps? Yeah, so if n is less than n, print ln minus 1. I don't have to do anything else. Uh, what is the minimum number of uh, if n are equal to 1 or are equal to 2, return 1 is return uh, I think rec I minus 1 plus I minus 2 or dp of I probably. Mm, mm, I think I should do okay. Now I want to find the minimal distance from some multiple of k to, right? So we want the dp of n. Let's try to print dp of n first. Hmm, 256. So 55. No, we don't want the number of wins, right? Okay, is it always 10 by 2? Is it always n by 2? C log n by 2. That is 5. This is, I don't need any DP. Moves n C div n2. So that's the moves I require actually. But while it has to be a multiple, so how to find the nearest multiple? I think m is up to m is okay. M can be, oh no, m is not one. So if moves modulo m equal to 0, print ln moves. Okay, or I can just probably do a brute force here. 10 if minimum number, right? Uh, let's think that so moves modulo m is some, let's say I need some number of moves. Now I want the nearest multiple of m around this moves. Let's say p equal to 1 while p is less than moves p is going to equal to m. Now I have just kind of crossed it. So maybe uh, int r1 equal to uh, maybe minimum, or I should say this p div p and 2, just higher multiple and then print. Why is r1 a problem? Okay, r1 is return 1, so raise. It's not like I can reach there with less than that number of moves, can I? This would still pass. So 4 p into equal to m, like, no, p equal to, okay, p equal to m. We first want to be m. Okay, p plus equal to m. Properties. 0 plus, what's it? 3. M is 2. P is 0. P is less than moves. What is moves? Moves is, P are moves. It's 5. Moves is 5. And moves modulo 2 is not equal to 0. Hmm. Print P. Okay, I think I should just print this P. Okay. Let's try to submit. Nice, accepted. This was also a 1000 rated problem. Easy, but it's not like I'm a candidate master anyways. So not so easy for me, I guess. Let's go back to problem set. Uh, I think we had some tags set up. Let's see how long the stream is running. Let's solve this problem. Oh, let's solve this one. 1200 rated. EB construction. Looks nice. Yeah, this is 1200. So there is a string key of such n such that Ti is A for all odd Ai and B is okay. So basically A, B, A, B. So A, B, A, B, A, B. So one day Bob generated initialize S to an empty string, remove either the first letter or the last letter from T and append it to S. Okay, so I have A, B, A, B stuff. Either I can take A, okay. Then Bob wrote down the generated S. Now he forgot. The note was worn down, and someone might have simply changed some letters. And of course, Bob wants to know if someone did alter the string, which consists of this. Please remind if there is a string S. Okay, and it's like any up to 200,000, so the difference about 5x. Okay, so there is no question mark, so always yes. This B A B A B A A B A. I have to make A B A B. So A I took, B I took. Then I want an A, so A I took. Then I so it's A B. Sorry, B A A B. So I think A B A B I want. So I had A B A B A. So I must have taken from A. So A cancelled. No, I mean I started with a B. It says okay, yeah. So first and the last letters are A in A B A B A. How can I start with a B? It's impossible. But let's say question mark B, question mark A B, and I have A B A B. So I can probably take A and maybe put the first letter as A. Then I can take B, good. Then I can take A, good. Then I can take A and then a B. Third one, sorry, fourth one, uh, A question mark B question mark B. So A B A B A I have. So A I take, good. A I take, good. Question mark has to be B. So let's take a B. 3, 4, 5, 6. Mm, sorry. So A I took. A I took. Now I have B's only. And I cannot start with the A. The question mark means I can replace it with either A or B. That's good. So I just want to know if I can generate this stuff from ABAB sequence, right? Let's try. So let's take n, let's say S of size n, so if I1, I think we can start from, let's start, let's do n plus 1 only. Okay, so if it is at 1, I know only one, so I think I will need to repeat 2, and then let's say n, after I can go up to n, and let's say step 2, let's say S of I equal to B. Now I have this AB sequence of length, right? Now I want to create this string S create, let's say T uh, equal T and then C in T. Now uh, the problem is if all of them are question marks, then let's say if it is a question mark, and let's say in my string S, uh, on one end I have A and on the other end I have B. Which one to take? So two choices. So BP of I, and of course the I0 means um, so let's say I have a length string n, length and string, okay. So if it is a, then if on the front or on the back, if I have a, BP of I a is 1. If it's B, then DP of I B is also 1. Otherwise, false. If it is question mark, DP of I, mm, I can take either a or a B. So let me tell you this approach I'm thinking that. So let's say A, B. Let's say I have this, and let's say I have some string that I want to generate A, B, B, A, question. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So here I can have this A. Let's call this. Here I can have this B. Here you see I have A or a B. Now question. Now this question mark, I can put anything, either A or B, right? So if this is L, this is R. So I can put, let's say this is some sort of LR TP situation. Like let me try to define the recurrence. That if idx, or let's say the t of idx is not equal to question mark, then I will check. Uh, I know that in S, if both of them are A, then there is bound to be B here. So it does not matter which A I take. So res return uh, uh, so L plus 1 R. If L is greater than R, return true. Okay. If T of IDX is not question mark. If T of IDX is question mark, so I can either return uh, L plus 1 R or R minus 1, L R minus 1, right? So two choices. Problem will arise when this will be given. So in this case, I can memorize something, but I cannot have a two-dimensional DP of LR. Like L and R can both up to the 10 to the power 5 because you see that n is up to 2 into 10 to the power 5. Let's write this brute force first, then probably we'll try to optimize something. So let's use the recurrence function. Do I have the recurrence function? No, I don't. So to recurrence. So, uh, so if L is greater than R, return true. If T of, okay, I need an IDX as well. Equal to not equal to uh, question mark. If it is not a question mark, if S of L equal to T of IDX, or S of, then return that's rec uh, L plus 1 or IDX plus 1, of course. L and then R minus 1. Or I can say that if I dx, uh, L's Reddenhouse, right? If it is not equal to question mark, but if it is equal to question mark, then we want to check. So basically, we want to return uh, this rec of L plus 1R or R plus 1. I mean L R minus 1. Of course, index plus 1. Now, I think in all of these cases, sorry, REC, we have this self, comma, and then I think we will have self here as well. So maybe rec, uh, rec itself, L will be 0, R will be n minus 1, and X will be 0. Hmm. Okay, so maybe if this, let's say if this py, otherwise p, do I have PYPN? Yes, we do have. Let's try. We'll definitely need to memorize this or do something about this. Hmm. Yes, 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 yes. Okay, let's try to print pizza pie. Hmm. Okay, so this is passing. Now we have to think about memoizing this somehow. Let's try to submit how many test cases it passes. Let's see. This will fail, obviously, but sometimes writing the recursive solution is time limit exceeded on some high test accepted. How is this accepted? What is the complexity of my solution? Like, yeah, it's fully recursive. Mm, this I did not expect. Uh, like, I mean, the amortized IDX is always increasing, right? Hmm. Some of test cases here is stupid or five. It says that it's DP, but I did not apply any DP here. Hmm. Let's try to prove the time complexity of this solution is order of n. Because IDX is always increasing. L plus 1 are increasing, L r minus 1 increasing. If let's say I have five question marks, every time there will be two function calls. Wait, uh, yeah. Hmm, hmm. Like the best idea I can come up with is that since IDX is always becoming IDX plus 1, maybe uh, some compiler level optimization is being done. Mm, if you can think of some, like, if you can think of an idea why this is passing, uh, for n is up to 10 to the power 2 into 10 to the power 5, please do let me know. Uh, I think we have solved three questions today. Thank you very much for watching. Next day we will continue from the next, the next problems, I guess. There will be more 800 to 1200 rated problems. We will try to not go below 1000. We will try to always stay around 1000 to 1200 rated only. So this was also 1200 rated as it is. After we have solved around 100 to 200 problems on, let's not say 100, let's say around 50 problems on 200 or 1200, I mean. we can proceed from 1200 to 1400. Then again 50 to $100, then 1400 to 1600, and we will go on until I become probably expert or Canadian master, which will probably take infinite amount of time. Thank you very much for watching. I hope you enjoyed. Have a great day. Bye.